understanding of the circuits is Kirchhoff laws. Coming to the Kirchhoff laws, here we have two types of laws are there, Kirchhoff voltage law and Kirchhoff's current law. Coming to the Kirchhoff voltage law, the algebraic sum of all branch voltages around any closed path in a circuit is always 0 at all instants of time. At all instants of time, the voltage across each and every branch, the voltage across all branch voltages around any closed path, algebraic sum is 0, always 0. So now look at here, in this circuit we have three different elements are there. Across each and every element there is a voltage drop is there, V1, V2, V3 like that, and here active element is V1. So according to our definition, this V1 must be distributed equally across each and every element, and if I add them, I have to get the same voltage which is supplied by the source. So here if I consider V is the supplied voltage, V1, V2, V3 or V2, V3, V4 are the voltage that is supplied to these elements, then according to our Kirchhoff voltage law, I can directly write down the V equal to V1 plus V2 plus V3. This is the Kirchhoff voltage law. Coming to the Kirchhoff's current law. So coming to the statement of current law, the sum of electric currents entering a particular node. So here node is nothing but a meeting point of two or more branches is nothing but the node. So sum of electric currents entering a node in an electric circuit is equal to the sum of currents leaving that particular node. Now look at here, in this diagram, I1 and I2, I4 are the entering currents, I3 and I5 are the leaving currents from this particular center node. So here I can write down this equation. Whatever that is leaving, I will consider them as the positive, and whatever the current that is entering is the positive and leaving currents as the negative. So based on that, based on the Kirchhoff's current law definition, I1 plus I2 plus minus of I3, because it is leaving, but I am considering the entering currents in the case, so I can write down a negative polarity for that, and then I5 which is also leaving. So the algebraic sum of, or the sum of electric currents entering the node in an electric circuit is equal to sum of electric currents leaving that particular node. Based on that, I can write down the relation as I1 plus I2 plus I4 equal to I3 plus I5. So these are the basic Kirchhoff laws, and then and based on these elements we'll have, so above all, what are the basic elements that are there? Here we have passive elements just like a resistor, inductor and capacitor, and then active elements which are nothing but the sources, which can be either the combination of independent and dependent, and the parameters that we are considering here is current or the voltage. And the basic laws that we have gone through is Ohm's law, Kirchhoff's voltage law and Kirchhoff's current law. So here we have gone through all these basic level of understanding regarding the network or the basic. And here we are going to discuss about one of the theorem, as these are the network theorems which are available and which are there already, but here we are going to discuss only one particular theorem, that is nothing but the superposition theorem. Now look at here. So when two or more sources are there, in a particular circuit, and if I want to find out the response through any particular element, then the particular response through that particular element will be the algebraic sum of the responses which are developed or which are because of the individual sources, by considering other sources are inactive. So this is about the statement of the superposition theorem. Now this is the statement, just look at here. In a linear network containing more than one independent source and dependent source, the resultant current in any element is the algebraic sum of the currents that would be produced by each independent source acting alone, all other independent sources being represented by their internal resistances. So in this current, first one, in this circuit, In this circuit, I need to find out response through 2 ohms, that is R2 resistor. Because of this, when both sources are acting and individual sources are acting alone. Now in this, there is a procedure to find out. What is the procedure to follow is, first find the current through resistance when only one independent source is acting, replacing all other independent sources by a respective internal resistance, and then find the current through the resistance for each of the independent sources. And the third point is, find the resultant current through the resistances by using superposition theorem, considering that magnitude and direction of each current. Now coming to the how we can replace the internal resistance of sources. So in case of the internal resistance of sources, if I have a voltage source, if I want to replace with the internal resistance, for example, according to Ohm's law, I know that V equal to IR. For making V equal to 0, the corresponding R must be 0, which is nothing but the short circuit. So the internal resistance of the voltage source is replaced with short circuit. The internal resistance of the voltage source is replaced with short circuit. And coming to the current source, as we know the Ohm's law, V equal to IR. For making I equal to 0, I need to consider R as infinite value. So here I equal 0, nothing but the open circuit. So internal resistance of the current source, the internal resistance of the current source must be replaced with the open circuit. So this is about the superposition theorem. Now look at here, this is the example in which first case we will consider the current passing through 1 ohm resistor with single voltage source alone. That means first source is 28 volts battery, acting only that particular battery, and the remaining sources will be inactive. In the case 2, current passing through 1 ohm with a 7 volts battery. Again the second source or the first source must be inactive. You have to replace with the internal. So accordingly we have to solve this circuit so that we will get the resultant or the algebraic sum of the voltages or the currents or the response through particular branch by considering individual sources acting alone, and the remaining sources by replacing them with the internal resistance. So this is what procedure that we can follow for doing the or for analyzing the superposition theorem, for solving the circuit for the superposition theorem. Thank you.